What's up, guys? Back to math. We are factoring in this section, and make sure you guys are all ears as you are watching this video. And just, I hope you enjoy watching me as I can be my true elf in this video. But factoring is kind of a tricky topic that you will be doing now and again in 8th grade, 9th grade, 10th grade, 11th grade. You're going to be doing factoring a lot from here on out. So let's learn the basics now so you don't struggle later. We're going to start on page 259. So if you guys want to find your workbooks and go to page 259. Before we get into factoring, let's talk about something called a monomial. Mono, this prefix means one, okay? And a monomial is a number, a variable, or a product of a number and one or more variables. For example, 2x is a monomial because it's a product of 2 and x. X plus 4 is not a monomial since it's the sum of two monomials. So a monomial is an expression that is only one term. This actually has two terms, x and positive 4. So this would be called a binomial, which we'll get into later. There's trinomials and so on and so forth, but monomial is one term. So there's no addition or subtraction separating terms. It's just a single term, but it could be a number or a variable or a combination of numbers and variables. So on page 259, you can fill these in and write them in the appropriate boxes. These are monomials. These are not monomials. So negative 12, what do you think? I think that goes there. 60 times x. So you can separate things with multiplication, but you can't separate with addition and subtraction. So this would be not monomials, and this one would be a monomial. And let's check. Ooh, yes. I know what I'm doing. Now, you also need to learn and know how to find the greatest common factor of monomials. So just like we can factor numbers, like finding the common factor of 12 and 24, the greatest common factor would be 12, right? We can find the greatest common factor of a monomial. So not just numbers, pairs of numbers, but also pairs of monomials, or more than two. We can find the factors and the greatest common factor. So to factor something means to write it as a product of its factors. So like for instance 12, the factors of 12 are 3 and 4. A monomial can be factored using the same method we would use to factor a number, and the greatest common factor is the greatest monomial that is a factor of both. Okay? So for instance, a number, the GCF of 25 and 30, if you think of factors of 25 and factors of 30, the greatest common factor is 5. The greatest common factor of this monomial would be 5x, because 5 is in common to 25 and 30, and they each have an x in common. So the greatest common factor to this monomial is 5x. So if you guys go to page 260 and look at page 260, we want to find the GCF of 12y and 30y. So we can start by looking at just the coefficients, 12 and 30. If I want to find the factors of 12, well, let's use blue to find the factors of 12. 1, 2, 3, 4, 6, and 12 are factors of 12, right? 1 times 12, 2 times 6, 3 times 4. Factors of 30 would be 1 times 30, 2 times 15, 3 times 10, 5 times 6, and I think that's it. So now, what do they have in common? 1, 2, 3, and 6. And what is the greatest common factor then of these that are in common? Well, the greatest one is 6. Ooh, there we go. Now we find the greatest coefficient of the variables. So if you look, what variable do they have in common? Or do they have a variable in common? And in this case, the common variable is y. So the common variable is the GCF of the variables. So that GCF is y. And so our final answer, the GCF of the entire expression, is the GCF of the coefficients and the common variable. So 6y would be my GCF for this one here. So pause the video, see if you guys can find on page 260, the check problem, the GCF of 24a and 32a. And let's look at another example. This one's not in the book. You can write this in the margins of page 260. Find the GCF of 12x and 28x. So first of all, 12 and 28, what would be the greatest common factor of 12 and 28? What's the biggest number that's a factor of both of these? And if you don't know, you can write the factors of each of them, if you know what the factors are. 1, 2, 4, 7, 14, and 28 are the factors of 28. So what do they have in common? The largest number that they both have in common is 4. And then they also have an x in common. So 4x is going to be the GCF here. So after those examples, if you still can't do the check problem on page 260, we can talk about it in class tomorrow. All right, another way we can find GCF is by prime factorization. So in the last example, we listed all the factors and found the ones in common, but you can also prime factorize both of these numbers. So prime factorization is basically all the factors of 18 that are prime. So we can't simplify it any further. So 2 times 3 times 3 times a is the prime factorization. One way to do the prime factorization, I don't know if you guys learned factor trees, but the factor tree of 18 and, or 18, we can multiply. 18 is the same as 2 times 9, and then 9 is the same as 3 times 3, and these are all prime numbers, so we can't go any further, so this would be the prime factorization of 18, 2 times 3 times 3, and then also times a. And then we could do the same thing with 20. 20 is the same as 4 times 5, and 4 is 2 times 2, and now all of these numbers are prime numbers, and so we can't break that down any further. So this is 2 times 5 times a times b. So you can find the prime factorization of each of the each of the monomials, and then the common factors in each term. We have, each one has a 2 and an a. So 2 and a are the only common factors here. But our GCF then would just be 2a here. Okay. So you can either list all the factors or you can find the prime factorization. Let's look at another example of this. If we want to find the GCF, again, you can use either method. So we can list all the factors or we can find the prime factorization. So let's look at 25 and 15 first of all. 25 is 5 times 5. And these are both prime numbers. The only other factors of 5 are 1 and itself. 15, prime factorization is 3 times 5. Ooh. And these are also prime factors. So 3 times 5, both prime factors, 5 times 5, both prime factors. So the prime factorization of, oops, didn't want to do that. Prime factorization of 25y is 5 times 5 times y. Prime factorization of 15xy is 3 times 5 times x times y. So now if you look here, what do these have in common? They each have a 5, and they each have a y. Is there anything else in common? Nope. So the answer, the greatest common factor of these two monomials is 5y. So you guys try on the middle of page 261. There's another chalk problem for you to do, and we will stop there for today. I hope you could hear me okay, and don't forget to always be your elf. And also don't forget to have your parents sign page 261 for you. All right, you guys, have a great night, evening, afternoon, whenever it is that you're watching this.